A floating hotel on the sea completes one full rotation every 24 hours, allowing every guest to enjoy panoramic ocean views. This project, called the ECO Floating Hotel, was designed by Harry Attack Architectural Design Studio. The hotel covers 35,000 square meters, has 4 floors, and contains 125 rooms. Guests can arrive by airplane, speedboat, or via a floating bridge that connects to the mainland. Its architectural form and operating concept were inspired by ocean whirlpools. The 24-hour rotation system uses dynamic positioning, computer-controlled to automatically maintain the hotel's position. Following a zero-waste principle, a set of propellers and thrusters located below the waterline provide rotation. The flowing water generated by the movement is also converted into electricity, making the hotel partially self-sufficient. The surroundings of the hotel are filled with greenery, giving visitors the feeling of being embraced by nature. The design also integrates rainwater collection, where sloped rooftops capture rain, wastewater is treated for irrigation, and food waste is converted into fertilizer for reuse. With such a stunning and luxurious sea view concept, wouldn't you want to experience staying here yourself? The worker pulls out a glowing red-hot tube from the mold. Its manufacturing process is quite special. It's made by spinning, known as centrifugal casting. Molten metal is poured into a high-speed rotating mold. The centrifugal force generated by the rotation spreads the molten metal evenly along the mold's inner wall. As it keeps spinning, the slowly cooling metal becomes denser, while impurities are pushed to the surface. Once it solidifies and takes shape, it can be pulled out. Different shapes can be made depending on the design of the mold. This is similar to rotational molding, but not the same. In rotational molding, the mold rotates very slowly, at most a few dozen revolutions per minute, and relies on the weight of the plastic solution to form. But in centrifugal casting, the mold rotates at least several hundred times per minute, sometimes even thousands depending on the product. Only with such strong centrifugal force can the molten metal fully fill the mold cavity and form high-quality castings. An unmanned vehicle designed specifically for military logistics missions can not only navigate and plan routes autonomously, but also operate normally in complex battlefield environments where GPS signals are jammed. This new autonomous ground vehicle, called the Bumblebee, was introduced by Jack Defense Enterprises, LPP Holdings. It is 2.8 meters long, 1.6 meters wide, and under 1 meter tall, offering good concealment and terrain adaptability. Powered by a hybrid electric system, it has a 350 kilograms useful payload capacity and can carry medical equipment, ammunition, or reconnaissance sensors. The vehicle is equipped with a multispectral imaging suite that greatly enhances surveillance and recognition in complicated environments. Bumblebee features a fully autonomous control system and does not require remote human control to independently navigate and plan routes in unfamiliar terrain. Bumblebee has already attracted strong interest from the Ukrainian armed forces, which are considering adopting the system to improve frontline logistics and rescue efficiency. Its development demonstrates the broad applicability of autonomous systems in high-risk environments. Future military logistics and battlefield support are sure to be fundamentally changed by innovative systems like Bumblebee. Loading liquefied natural gas at -162 degrees Celsius into a transport ship is no simple task. Don't be fooled by those few giant spheres on the vessel. Building them is as difficult as constructing an aircraft carrier. So, what's inside them? The entire ship has a double-hull structure, with a space in between that can be filled with water to serve as a ballast tank. In case of a collision, this design helps protect the LNG tanks. The most critical components are the massive tanks themselves. They are independent of the hull and supported by high-strength steel. Each tank has multiple layers. The innermost is the so-called Invar alloy membrane, which has an extremely low expansion rate and stays stable even at -196 degrees Celsius, while being only about 0.7 millimeters thick. Welding it together is extremely difficult, and that's one of the main reasons why LNG carriers are so hard to build. Surrounding this layer is insulation made of polyurethane foam, and the outer layer is a protective shell of nickel steel or high manganese steel. The space around the tank is also filled with inert gas for fire prevention and heat insulation. After extraction, natural gas is cooled to -162 degrees Celsius, turning into liquid and shrinking in volume by 600 times. Once liquefied, it can be loaded onto the ship. Many people think it's just a matter of pouring it in, but the process is far more complex. Each tank has a central column with 4 pipelines, a filling pipe, a vent pipe, and 2 spray pipes. At the bottom of the vent and spray lines are pumps. Because there may be moist air inside the tank, the process starts by injecting dry air to push out the humidity. Then, inert gas is pumped in to replace the dry air. After that, gaseous natural gas is added to displace the inert gas. Now the tank contains only gaseous natural gas, which means liquid LNG can finally be loaded. Even then, the tanks are never filled completely. Some space is left to relieve pressure. During long voyages, heat gradually seeps in, causing a small amount of the LNG to re-evaporate into gas. This boil-off gas isn't wasted, it's piped directly to the engines and used as fuel. Once the ship reaches port, the LNG must be converted back into gas. This requires absorbing a huge amount of heat. Since that energy cannot be wasted, the regasification process can actually be used to cool power plants. The specific principles were explained earlier, so I won't repeat them here. If you're interested, you can look up cold energy power generation. This is Oaka, a general-purpose humanoid robot released by Sion Qingxin Innovation. It stands 145 centimeters tall, weighs 40.5 kilograms, and features 28 degrees of freedom across its body. Its arms can carry objects weighing between 3 to 5 kilograms. In addition to normal upright walking, it can also spin in place, climb slopes, and even perform splits. It can autonomously match emotional expressions, displaying happiness or sadness, which has earned it the title of the most human-like robot among netizens. With the support of large language models, its speech comes with emotional expression, making it sound less like a cold, mechanical AI. The robot is equipped with 3D LiDAR and a depth camera, and its end-to-end dual-arm control gives it dexterous manipulation abilities. From demonstration videos, we can see it operating machines, such as using a coffee maker to brew coffee. In the future, it may even serve as a household nanny. Oaka will officially begin pre-sales within this year and enter mass production in 2025. Perhaps in just a few years, humanoid robots like this will become common household helpers, assisting families with daily chores. This is the moment when the cast is being cut open. It's very clear that the saw blade touches the skin, yet nothing happens. So how is that possible? I always thought the blade worked by rotating to cut through the plaster, and since it wasn't sharp, it wouldn't hurt the skin. But that understanding was completely wrong. On closer inspection, the blade doesn't rotate at all. It actually makes small back-and-forth oscillations. Now it makes sense. When the blade meets the hard plaster, it grinds through it directly. But since human skin is flexible and elastic, when the blade oscillates, the skin just moves along with it. So even though there's contact, it doesn't grind into the skin. This oscillation works on the same principle as a multi-tool. Because the shaft on the eccentric wheel is not aligned with the motor's axis, when the motor spins, it creates eccentric motion. That motion is then transferred through a connecting rod to the tool head, converting it into side-to-side oscillations. In simple terms, whether it's a cast saw or a multi-tool, both use the principle of soft overcoming hard. They cut through hard material but not soft tissue, effectively neutralizing the blade's friction. That's why even if the saw touches skin, it causes no harm.